Okay, here we go. Key words to learn for the electricity topic in Key Stage 4. A continually oscillating. So what that means, continually oscillating, means going backwards and forwards, which results in the potential difference, the voltage, across 2 points continually oscillating between positive and negative. So it looks a bit like that. That is alternating potential difference, often put down as AC. The unit of current, amps. The force pulling two opposite charges together, so you've got a positive and a negative, attraction. The unit of charge, coulomb, right? I'll often say it as coulomb, right? To remember that B on the end there. A component that only allows current to flow through in the forward direction. Okay, so it looks a bit like a triangle like that. Okay, circle around the outside of it. Okay, that is has very large resistance in the reverse direction, so it allows electricity to go through that way, but it doesn't that way, is a diode. A one-directional current flow, DC, direct. The green and yellow striped safety wire that prevents an appliance from becoming live. Okay, so it's the one at the top. The longer pin on the plug is the earth wire. The rate of flow, so it's the flow of electrical charge. Its value is the same as any position in a single closed loop. Current. A light emitting component, there we have it, it's like a cross, of an enclosed metal filament. Its resistance increases as the filament temperature increases. Filament lamp. The coating around power cables that prevent electrocution, so if you grab a wire you're not going to get electrified. Insulation. A light sensitive component whose resistance increases as the temperature decreases. Okay, so it's a resistor. Okay, and it's light dependent. LDR. The brown coloured wire that supplies the alternative current from the mains. Live and brown, dangerous. An AC supply which UK has 50 Hz and 230 volts is mains electricity, so any computer or anything like that you're using connected to the mains, 50 Hz, 230 volts. The blue wire, okay, like the sea or the sky, the blue coloured wire that completes the circuit is the neutral wire. A force experienced between two separated objects, okay, so two magnets, north, south, that's supposed to be an N, is a non-contact force. A conductor whose current flow is directly proportional to the potential difference across it. So what you have is you have a graph that looks a bit like that, all right, and that's a straight line graph, and that is an ohmic conductor which is directly proportional to the potential difference. The unit of resistance, ohms. Sometimes I like doing it as like a funny little horseshoe or a hat or something like that. Components connected in parallel have the same potential difference. Okay, so parallel is where you've got different circuits like that. The total current is equal to the sum of the currents, parallel. The product of a component's resistance and magnitude of current flowing through it, potential difference. This is caused when two like charges are brought next to each other. Okay, so if I've got a north and a north, what they do is they don't want to go anywhere near each other. Repulsion. A measure of the opposition, right? So resisting, resistance. The total resistance of two parallel resistors is always less than the lowest. Okay, so what you got is you've got a resistor, you've got a resistor, you've got a wire there. Okay, you got wire there, right? That's a resistor, that's a resistor. What is the total resistance? It's less than the smallest resistor. The total resistance is equal to the sum. So if you've then got resistors in series like that, then what you do is you add them up. Components connected in series have the same current passing through each component, but they share the total difference. So if you've got electricity passing through a series circuit, it's the same amount of current. So that is a series circuit. Device is found between the transmission cables, so near the house, and the consumer that lower the potential difference of the power. step-down transformer. The opposite of that, where it comes out of the power station, is a step-up transformer. All of the wires, so the network of power stations, transformers and cables that connects consumers to the power stations, is the national grid. A temperature dependent component whose resistance increases, okay, is a bit like that, okay, not the best one in the world, okay, and what I always think about it's like a hockey stick, so it kind of goes like that. Thermistor, the unit of potential difference, volt. Right, there's lots of definitions in there, lots of keywords, right, some of them are a little bit tricky, I think. Pause the video and make sure you write them down onto a piece of paper, your answers. Okay, turn your page and do them again and make sure you don't cheat, and make sure you also get all those ones that you got wrong the first time, check them out and make sure you get them right the second time. Okay, well done. Right, some tricky stuff in there, right, some tricky definitions to try and work out, right, but try and work out exactly what the word is from the definition itself. It might sound stupid, right, but you've just got to be able to use these or do this in your exam, because that's what the marks are all about.